It began as a whisper across deep space networks, anomalous readings, impossible vectors, numbers that should have collapsed under their own contradiction, but they did not. Instead, they pointed to one object, an object moving through our solar system with a calm defiance that felt almost surgical. 3I Atlas. NASA analysts stared at their screens as a simple truth emerged. 3I Atlas was violating a mechanical constraint that every atom in the universe must obey. A law that cannot bend. A law that cannot crack. A law that nothing has ever broken. Yet across every tracking baseline, across separate observatories, across independent calibration chains, 3I Atlas was breaking it, openly, consistently, and without hesitation. The first reaction was disbelief, then panic, then something far colder. The realization that the universe itself had been forced to reveal a secret it never meant to share. And as the data continued to stream in, as the numbers held firm, as the paradox refused to resolve, NASA initiated a crisis-style review usually reserved for existential threats. Because if 3I Atlas was truly breaking a fundamental law, then every part of physics tied to that law would need to be questioned, rewritten, or abandoned. Something was wrong with the universe. Or something was wrong with us. To understand how this began, we return to the night 3I Atlas was first detected. The discovery came from a survey program scanning for fast-moving interstellar visitors. Objects like ʻOumuamua and 2I Borisov had taught us that interstellar wanderers are not rare. But what the survey team found on that night was different, sharper, stranger, more deliberate in its signature. 3I Atlas entered detection range with a velocity profile that immediately stood out. It moved like an interstellar object, but its acceleration curve showed a deviation so small that early logs flagged it as a math error. Yet the error repeated, night after night, scope after scope. The European Space Agency independently confirmed the anomaly. Soon after, ESA observatories verified that their tracks matched the NASA fit. No drift, no correction. No correction factor that could erase what the measurements demanded. 3I Atlas was moving in a way that violated the most basic mechanical expectation. Not by a dramatic amount, not by an explosive signature, but by a precise and consistent deviation that no natural object could produce. Astronomers began combing through early images, examining its faint halo, comparing it against known cometary objects. But the more they looked, the less sense it made. Its trajectory suggested a deep interstellar origin, yet its composition, hints were muted. Its brightness curve refused to behave like a comet or an asteroid. 3I Atlas was not chaotic, not fragmenting, not venting gas. It was stable, controlled, predictable, and that stability only amplified the paradox. When NASA realized that every independent tracking baseline produced the same impossible metric, the alarm escalated. 3I Atlas was not just another interstellar visitor. It had become a threat to the foundation of physics itself. To understand how 3I Atlas was breaking a physical law, we need to simplify the science. Objects moving through space obey predictable rules. Their paths curve under gravity. Their speeds change with force. Their momentum holds unless something interacts with them. These rules are not guidelines. They are the skeletal structure of reality. And yet the motion of 3I Atlas displayed a pattern that requires a hidden force, a silent push, a non-gravitational influence that shifts its momentum without any detectable mechanism. No jets of gas, no thermal recoil, no radiation pressure anomaly, no mass loss. Imagine watching a ship drift across a calm ocean. No wind, no waves, no engine. Yet it slowly angles left, not at random, but with intention, with consistency. This is the behavior 3I Atlas shows as it cuts across the solar system. NASA teams checked for instrument drift. Nothing. They applied every solar pressure model available. Still wrong. They tested thermal recoil models. Still wrong. They tracked it with radar, infrared, optical, across the James Webb Space Telescope, then from Webb via follow-up deep field inference. and from the Hubble Space Telescope archives, and from Hubble follow-ups, the deviations remained. Every model said it should move one way. Every measurement said it moved another. To break this law, 3I Atlas would need access to a force we do not understand, a state of matter we cannot detect, or an engineering principle far beyond natural formation. Its shift is not violent. It is subtle, almost gentle. But that gentleness is what terrifies physicists, because gentle violations are harder to explain, harder to blame on chaos, harder to hide behind natural variance. The anomaly is too consistent, too narrow, too clean. It behaves like a calculated correction, a refined course adjustment, as if something is guiding it, or as if the object itself obeys a rule we have not discovered yet. The deeper the investigation goes, the stranger 3I Atlas becomes. One of the earliest oddities is its energy budget. It maintains a kinetic profile that implies either an ancient origin or an engineered injection trajectory. Its composition appears darker than typical comets, yet more reflective than carbonaceous asteroids, a contradiction that should not exist in nature. Another mystery is the micromodulation in its brightness curve. It does not flicker like a tumbling rock. It pulses with a slow and measured regularity, a pattern that resists natural explanation. Not enough to declare artificiality, but enough to raise eyebrows in the control rooms. Then comes the thermal paradox. 3I Atlas absorbs more sunlight than expected, but emits less heat than physics predicts. It behaves like a body that stores energy or redistributes it internally, or channels it in a way no natural material can. And the biggest mystery of all is the violation itself. The mechanical constraint it breaks should be absolute. Galaxies obey it, stars obey it, planets obey it, spacecraft obey it. Every particle of matter ever tested obeys it. But 3I Atlas does not. NASA built crisis models, tested for uncomputed drag, looked for interplanetary dust pockets, checked for solar-wind interactions. Everything failed. Even more unsettling. The violation does not increase as the object approaches the inner solar system. It does not decrease as it moves outward. It is constant, predictable, perfectly tuned. As if 3I Atlas is not responding to the solar system, as if it is responding to something else entirely. Some physicists speculate a hidden symmetry, a new field, a missing term in the equations that govern motion. Others whisper about engineered navigation, not as a declaration, but as a last resort when nature refuses to cooperate. The object forces us into a corner, and that corner feels uncomfortably small. What comes next may reshape physics. If the violation holds through the remainder of its solar passage, humanity will face a choice. Either rewrite the law or discover what 3I Atlas is using to bypass it. New missions may be drafted. Deep space probes aimed at its trajectory. High-intensity tracking campaigns that combine NASA ESA ground observatories and future orbital telescopes, all hunting for the missing mechanism. A breakthrough here could trigger a scientific revolution. A new force, a new interaction, a new framework for motion itself. It could lead to propulsion concepts that reach beyond chemical engines, beyond ion drives, beyond nuclear fusion, into a realm of physics once thought impossible. Or it could reveal something older, something built far from Earth, something that learned how to use the universe in a way we have not yet imagined. For now, we wait. We analyze. We question the laws we once believed were unbreakable, because 3I Atlas continues its journey, silent, stable, and unwavering in its defiance. And as it moves beyond our reach, leaving behind more questions than answers, we are forced to confront a truth that chills even the most seasoned scientist. If one object can break a fundamental law, then the universe may be far stranger, far deeper, and far less predictable than we ever dared to believe. The sky is not quiet, the laws are not final, and the next discovery may change everything.